When we add and subtract algebraic fractions, we follow the same general steps that we follow when we add and subtract fractions in arithmetic. Let's look at a problem. Perform the indicated operation. Usually the instructions when we add algebraic fractions are perform the indicated operation. When we add fractions in arithmetic, the fractions are usually written vertically. But in algebra, the fractions are more likely to be written horizontally. So I've written this problem horizontally. When we see a problem like this, we note the addition sign and we note the fractions. Then we think, we're adding fractions. And to add fractions, we need a common denominator. So the first step is to find the least common denominator. Remember, the least common denominator is the smallest number that each denominator divides into evenly and is referred to as the LCD. The least common denominator for 4 and 12 is 12. So let's write LCD 12. The next step is to multiply each fraction by the needed factor so that the resulting equivalent fraction has a denominator of 12. Since 4 goes into 12 3 times, we multiply both the numerator and the denominator of 3/4 by 3. Let's write the 3/4 plus the 5/12. Let's multiply by 3 divided by 3. Remember, 3 divided by 3 is 1. That's why the resulting fraction is an equivalent fraction to 3/4. We do not need to multiply the 5/12 by a factor because it already has a denominator of 12. For the 3/4, 3 times 3 gives us 9. 4 times 3 gives us 12. We will write the 5/12. The next step is to add the numerators. 9 plus 5 will give us 14. When we add 12ths to 12ths, we know that the denominator is 12, so we will write the 12. Notice the denominator is the LCD. The last step is to reduce. 2 will go into 14 7 times, and 2 will go into 12 6 times. So the answer is 7 6. When we add algebraic fractions, we shall follow the same steps. Let's go over those steps again. Steps for adding and subtracting algebraic fractions with different denominators. First, find the least common denominator. Next, we will multiply each fraction by the needed factor or factors so that the resulting equivalent fraction has a denominator that is equal to the LCD. We may then add and or subtract the numerators. We will write the LCD for the denominator. And last, we will reduce if possible. Take a few minutes and look at those steps. Now that we know the steps to follow, we are ready to add and subtract algebraic fractions. This is a list of all the problems I am going to work in this lesson. I have grouped these problems and color-coded them so that if you do not have time to view the whole tape, you can view one section, and then the next time you view the tape, hopefully it will not be too difficult to fast forward to the section you want to view. Before each set of problems, there is a blank screen and then a list of the problems worked in that section of the lesson. For example, there is a green screen. Next is a list of the problems worked in the green section. Each problem worked in the green section will have a green rectangle above it. Then there is a red screen, a list of these problems, and each problem will have a red rectangle above it. Then a blue screen, a list of these problems, and each problem will have a blue rectangle above it. I shall begin with the green section. If you would like to begin with a different set of problems, fast forward to the set you would like to view. Monomial denominators. Here are the problems I shall work in this set of problems. Problem number 1. Perform the indicated operation. The indicated operation is addition. I am adding fractions, so I know I need to find the LCD. The LCD for 4 and 12 is 12. So I will rewrite my problem. Since 4 goes into 12 3 times, I need to multiply 3x over 4 by 3 over 3 to find the equivalent fraction. Since 5x over 12 already has a denominator of 12, I do not multiply it by anything. 3x times 3 will give me 9x. 4 times 3 will give me 12, plus 5x over 12. Since my denominators are the same, I may add my numerators. Since my numerators are like terms, I may say 9x plus 5x is 14x. When I add 12s to 12s, the denominator is 12. Note, the denominator is the same as the LCD. My last step is to reduce. 2 will go into 14 7 times. 2 will go into 12 6 times. So my answer is 7x over 6. Problem number 2. Perform the indicated operation. The indicated operation is subtraction. I am subtracting fractions, so I know I need to find the LCD. This is the first time we've had a variable in the denominator. So let's talk about how to find the LCD when we have variables in the denominator. To find the LCD, we will factor each denominator into its prime factors. We will then write each different prime factor raised to the highest power that it occurs in any one denominator. Actually, for these fractions, the denominators are already factored into their primes. I have x over 2 times y, subtract 3x over 5 times y. My 2 and my y are prime factors. My 5 and my y are prime factors. When I write the LCD, I write each different prime factor raised to the highest power that it occurs in any one denominator. I have a factor of 2, a factor of y, a factor of 5, and since I have already used the factor of y, I do not need to use it again. So I have written each different prime factor. The 2 is raised to the first power, the y is to the first power, the 5 is to the first power, and the y is to the first power. So I only need to use each factor raised to the first power. So my LCD is 2 times y times 5, or 10y. I now need to multiply my 2y by the needed factor so that the resulting equivalent fraction has a denominator of 10y. I have my 2, I have my y, my needed factor is 5. So I will multiply the first fraction by 5 over 5. For my second fraction, I have my 5, I have my y, my needed factor is 2. So I will multiply by 2 over 2. X times 5 will give me 5x. 2y times 5 will give me 10y. Subtract 3x times 2 will give me 6x. 5y times 2 will give me 10y. I now have the same denominator, so I may subtract my numerators. Since my numerators are like terms, I may say 5x subtract 6x, which is minus 1x. My denominator is my LCD, which is 10y. Now usually we write the minus in front of the fraction, and then we'll write x over 10y. I check to see if that can be reduced, and it cannot. So my final answer is minus x over 10y. Problem number 3. Perform the indicated operation. In this case, I am adding and subtracting fractions. I need to find my LCD. Well, actually, my denominators are in factored form. When I write each different factor, I will write my x, I will write my y. I've already used my x and my y. My x is raised to the first power in this denominator and the third power in this denominator, so I need to raise my x to the third power. My y is used to the first power here and the first power here, so I only need to raise y to the first power. So my LCD is x cubed y. I now need to multiply each fraction by the needed factor so that the denominators are equal to the LCD. For the x, I need to multiply x by x squared to get the x cubed, and I also need a y, so I will multiply by x squared times y over x squared times y. For my second fraction, I have my y. I will need to multiply by x cubed over x cubed. And for my third fraction, I already have the common denominator, so I don't need to multiply it by anything. On my first fraction, 3 times x squared times y is 3x squared y. In the denominator, x times x squared times y is x cubed times y. Plus 5 times x cubed gives me 5x cubed. In the denominator, y times x cubed is x cubed y. Minus 2 over x cubed y. Since my denominators are the same, I may combine my numerators. My numerators are not like terms though, so when I combine them, I simply rewrite them. 3x squared y plus 5x cubed minus 2. All of that is over my LCD, which is x cubed y. I check to see if I can factor my numerator to see if I can reduce this fraction, but my numerator does not factor. So this is my final answer. Problem number 4. Perform the indicated operation. I would like for you to work this problem After you have worked it, I shall give you the correct answer and shall work the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Let's look at the answer. Did you get 25y minus 2x squared all over 15xy squared? If so, you may want to fast forward to the red set of problems. If not, you may follow along as I work the problem. I am subtracting fractions. I need an LCD. To get the LCD, I will rewrite my fractions and I will factor the denominators into prime factors. 3xy is already in prime factor form. For the second denominator, I will have 15y squared. I will write the 15 as 3 times 5 and then my y squared, and my numerator is 2x. When I write each different prime factor, I will have my 3, my x, my y. I've already used my 3, I need my 5, and I have already used a y. Now on the y, since y is used to the first power here and the second power here, I will need to use y to the second power. My 3, my x, and my 5 are all raised to the first power, so I only need to use them to the first power. When I multiply my factors out for my LCD, 3 times 5 gives me 15xy squared. Now, let's get our equivalent fractions. I would prefer to write this as 15y squared. I want to figure out what to multiply 3xy by so that the result is 15xy squared. I need to multiply the 3 by 5 to get 15. I have my x, and I need to multiply the y by y to get y squared. So we will multiply by 5y over 5y. For the second fraction, I have my 15, I have my y squared, I need my x. So I will multiply by x over x. For my equivalent fractions, 5 times 5y will give me 25y. 3xy times 5y will give me 15xy squared. Subtract 2x times x will give me 2x squared. 15y squared times x will give me 15xy squared. My denominators are now the same. I may combine my numerators. My numerators are not like terms, so I will simply write 25y minus 2x squared all over my denominator, which is 15xy squared. I check to see if I can factor my numerator to see if this fraction will reduce, and I cannot. So this is the final answer. On this problem, I usually use another method to determine that 15 is the numerical factor of the LCD instead of going through the prime factor process. I can look at the 3 and the 15 and determine that 15 is the smallest number that 3 and 15 divide into evenly. Therefore, I know to use 15 as the numerical factor of the LCD. That completes this section. Now let's move to the red set of problems. Binomial denominators. Here are the problems I shall work in this set of problems. I'd like to begin by reviewing the steps for adding and subtracting algebraic fractions with different denominators. First, we will find the least common denominator, the LCD. Then we will multiply each fraction by the needed factor or factors so that the resulting equivalent fraction has a denominator that is equal to the LCD. Next, we will add and or subtract the numerators and write the LCD for the denominator. The last step will be to reduce if possible. Let's begin with problem number 1. Perform the indicated operation. The operation is addition. We are adding a fraction to a whole number. We want to find the LCD. We will rewrite this problem. We will write 3x plus 1. We will look at the denominator. We will factor the denominator. This denominator is a prime factor, so we will write x minus 1 in parentheses as a factor. We will take the 2 and write the 2 over 1. When we find the LCD, we look at the factors of the denominators. We have a 1 and an x minus 1. 1 times x minus 1 is x minus 1. So we know that we will use x minus 1 for our LCD. We will rewrite the first fraction. Since it already has a denominator of x minus 1, we do not need to multiply it by anything. We will write the 2 over 1. We want the 2 over 1 to have a denominator of x minus 1, so we need to multiply it by x minus 1 over x minus 1. We will now rewrite the first fraction. We will multiply the numerator of the second fraction. We will distribute the 2 to the x and the minus 1. 2 times x is 2x. 2 times minus 1 is minus 2. In the denominator, 1 times x minus 1 is x minus 1. Now that the denominators are the same, we may combine the numerators. We will have 3x plus 1 plus 2x minus 2. Since our denominators are the same, we may write the denominator for our fraction, which, please notice, is the LCD, x minus 1. Let's combine like terms in the numerator. 3x plus 2x is 5x. 1 subtract 2 is minus 1. And let's write our denominator. Let's review our steps. We found the LCD. We multiplied our fractions by the needed factors so that the resulting equivalent fractions had a denominator of the LCD. We were then able to add our numerators. We wrote our LCD for our denominator. And for the last step, we need to check to see if this fraction can be reduced. Does this numerator factor? The answer is no, it doesn't factor. So this fraction is reduced. This is our final answer. Let's work problem number 2. Perform the indicated operation. In this case, the operation is subtraction. We are subtracting fractions. We will need to find the LCD. Let's rewrite the first fraction. Let's factor its denominator. X minus 3 is a prime factor. Let's rewrite the second fraction. Let's factor its denominator. 2x plus 1 is a prime factor. Let's decide what the LCD is. Let's get each different prime factor. X minus 3, 2x plus 1. Each of these factors is raised to the first power, so we will use each factor raised to the first power in the LCD. Let's now multiply each fraction by the needed factor, so we have equivalent fractions with the denominator equal to the LCD. Let's write our first fraction. What do we need to multiply x minus 3 by so that the denominator is equal to the LCD? We have the x minus 3. The needed factor is the 2x plus 1. So we will multiply both the numerator and the denominator by 2x plus 1. On the second fraction, we have x plus 2 over 2x plus 1. We have the factor 2x plus 1. The needed factor is x minus 3. So we will multiply both the numerator and the denominator by x minus 3. Now, when we work with this first fraction, let's multiply out the numerator. And when we multiply, we are multiplying a binomial times a binomial, so we'll use the full method. 2x times 2x is 4x squared. For an outer term, we get 2x times 1, which is 2x. For an inner term, we get negative 5 times 2x, which is minus 10x. Combining 2x and minus 10x, we get minus 8x for a middle term. For the last term, we say negative 5 times 1 is negative 5. Let's write the denominator. Write the denominator in factored form. When we are working with binomial and trinomial denominators and we're adding and subtracting algebraic fractions, we multiply out the numerators, write the denominator in factored form. Moving to the second fraction, I will multiply out my numerator. Once again, I have a binomial times a binomial. I will use full. X times x gives me x squared. For an outer term, x times negative 3 is negative 3x. For an inner term, 2 times x is 2x. Minus 3x plus 2x will give me minus x for my middle term. 2 times negative 3 will give me negative 6 for my last term. Let's write my denominator in factored form. Please note, my denominators are the same. The factors are in different order, but the denominators are the same. So I may combine my numerators. I write my denominator, which of course is my LCD. For my numerator, since I am subtracting, I want to emphasize that this subtraction sign applies to all three of these terms. So I'm going to write the numerator of my first fraction. I'm going to write my subtraction sign, but I'm going to write each term in the numerator of my second fraction in the parentheses to emphasize that this subtraction sign applies to all three of these terms. Let's go ahead and write the denominator. Let's write the 4x squared, subtract 8x, subtract 5. Let's apply the subtraction sign to all three of these terms. The subtraction sign will change the sign of all three of these terms. Or I may think negative 1 times x squared is negative x squared. Negative 1 times negative x is positive x. Negative 1 times negative 6 is positive 6. Now I may combine like terms in my numerator. 4x squared subtract x squared gives me 3x squared. Negative 8x plus x will give me negative 7x. Negative 5 plus 6 will give me a plus 1. And let's write my denominator in factored form. My last step is to see if I can factor my numerator, and if I can, if it has a common factor with my denominator. My numerator in this case will not factor. Since my numerator and my denominator do not have a common factor, this is the final answer. Let's work problem number 3. Perform the indicated operation. In this case, I am subtracting and I am adding. I know I need to find the LCD. Let's rewrite each fraction. As we do that, let's factor the denominators. 2y minus 8 has a common factor of 2, so I will factor my 2 out. When I factor my 2 out of 2y, I am left with y. When I factor my 2 out of negative 8, I am left with a negative 4. For my second fraction, I will have y over. Once again, I have a common factor in my denominator of 2. I will factor the 2 out. In my first term, I am left with y. When I factor a 2 out of positive 8, I am left with positive 4. Let's write my third fraction. Please note in my third fraction, my denominator is 4 minus y. That is the opposite of the factor that I have in my first fraction. Positive 4, negative y, positive y. 4 minus y is the opposite of y minus 4. Now I want to show you what I need to do with one of my factors if I have opposites. I will choose to work with the 4 minus y. The first thing that I'm going to do is to reorder the terms in this denominator. So when I rewrite this fraction, I'll write the 3 in the numerator, but in the denominator, I will write the minus y first and then my plus 4. Now, before I find the LCD, I want to work with this fraction that has an opposite factor in the denominator. Let's rewrite this first fraction. Let's rewrite the second fraction. And what I want to do with this opposite factor is to common factor a negative out of each term. If you want to, you may think that you are factoring a negative 1 out of each term. When I factor a negative out of a negative y, I am left with y. When I factor a negative out of a positive 4, I am left with a negative 4. I may think positive 4 divided by negative 1 gives me negative 4. The next thing that I want to do is just to rewrite this problem. Let's write the first fraction. Let's write the second fraction. Now when I get to this third fraction, I know that a fraction has three signs. It has a sign in front, a sign for the numerator, a sign for the denominator. In this case, I have an addition, the 3 is positive, and I have a negative. Any time that only one of these three signs is negative, that is the equivalent of having a negative out front. Another way to think about it is a positive divided by a negative is a negative. So I may rewrite this fraction as the subtraction sign, then 3 over y minus 4. Now I'm ready to find the LCD. Look at the factors in my denominators. I have a numerical factor of 2. I have a variable factor of y minus 4. And I have a variable factor of y plus 4. Look at each of those factors. Each of these factors is raised to the first power. So for my LCD, I only need to use each factor raised to the first power. Now that I've determined my LCD, I need to get equivalent fractions for each of my three fractions. So let's write this first fraction. I have a factor of 2 and a factor of y minus 4 in the denominator. If I want my LCD to be 2 times y minus 4 times y plus 4, then I need to multiply this fraction by y plus 4 over y plus 4. Y plus 4 is the needed factor. Let's move to the second fraction. In this denominator, I have my factor of 2. I have my factor of y plus 4. The factor I need is y minus 4. So I will multiply my numerator and denominator by y minus 4 over y minus 4. Let's move to my third fraction. I have my y minus 4 factor. I do not have my 2. I do not have my y plus 4. So I need to multiply by 2 times y plus 4 over 2 times y plus 4. Now let's multiply out the numerators. For this first fraction, I am multiplying 3y, a monomial, times a binomial y plus 4, so I will use the distributive property. 3y times y is 3y squared. 3y times 4 is 12y. I will write my denominator 2 times y minus 4 times y plus 4 in factored form. Please note, I multiply out my numerator. I leave my denominator in factored form. Moving to the second fraction, I am multiplying y times y minus 4. Y times y is y squared. Y times minus 4 is minus 4y. In the denominator, I will write my factors. Let's move to the third fraction. In the third fraction, I am saying 3 times 2, which is 6, and then I multiply my 6 times my y plus 4. 6 times y will give me 6y. 6 times 4 will give me 24. And I will write my denominator in factored form, but I want to write my numerical factor first. Now please note, my denominators are all the same. The factors are in different order, but my denominators are all the same. That means that I may combine my numerators. I'm going to go ahead and write my denominator. And for my numerators, I realize that I am subtracting, but instead of rewriting the subtraction and putting my terms in parentheses, I'm just going to go ahead and apply the subtraction sign. So I will write my first numerator, 3y squared plus 12y. When I apply the subtraction sign to the y squared, I get minus y squared. When I apply the subtraction sign to the minus 4y, minus a minus would give me a positive 4y. For this last fraction, when I apply the minus to the 6y, I will get minus 6y. When I apply the minus to the 24, I have minus 24. Now I need to combine like terms in the numerator. Let's write the denominator. The 3y squared subtract y squared is 2y squared. 12y subtract 6y would give me 6y, and then if I add the 4y to it, I will get 10y, and then I have a minus 24. Now, I have found the LCD. I have multiplied by needed factors to get equivalent fractions. I have combined my terms in the numerator. I have written my LCD as a denominator. What is my last step? Can I factor this numerator and see if this fraction reduces? Can I factor this numerator? Yes, I can. I have a common factor of 2. When I factor the 2 out, of the first term I have y squared. Of the second term I have plus 5y. Of the third term I have minus 12. In the denominator I have a factor of 2, a factor of y minus 4, and a factor of y plus 4. Since my 2's are both factors, I may cancel them, or I may think 2 divided by 2 is 1. I'm left with y squared plus 5y minus 12 over y minus 4 times y plus 4. Now, will my numerator factor? Can we factor y squared plus 5y minus 12? The answer is no. So my fraction is reduced. This is my final answer. Problem number 4. Perform the indicated operation. I would like for you to work this problem. After you have worked it, I shall give you the correct answer and shall work the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Let's look at the answer. Did you get this for the answer? Please notice that I wrote the numerator in factored form. If this was your answer, you may want to fast forward to the blue set of problems. If not, you may follow along as I work the problem. We are adding fractions. We know we need an LCD. Let's rewrite each fraction. When I look at this denominator is factored. 4x plus 1 is a prime factor. When I look at the second denominator, 4 is a numerical factor, and if I want to, I can factor the 4 into its prime factors, but I would prefer just to leave a numerical factor as itself, so I will write it as 4, and then I will have a factor of x. So when I find the LCD, finding each different factor, I have a 4, I have an x, and I have a 4x plus 1. Now, let's get equivalent fractions. Let's write this first fraction. Let's multiply by the needed factors. I have a factor of 4x plus 1. The factors that I need are the 4 and the x. So I will multiply by 4x over 4x. Let's look at the second fraction. I have the factor of 4, the factor of x. The factor I need is 4x plus 1. So I will multiply the numerator and the denominator by 4x plus 1 over 4x plus 1. On the first fraction, I will multiply out the numerator. 3x times 4x will give me 12x squared. I will write the denominator in factored form. 4 times x times 4x plus 1. For the second fraction, I am multiplying 3 times 4x plus 1 in the numerator. I will distribute the 3. 3 times 4x is 12x. 3 times 1 is 3. And I will write that over the denominator in factored form. 4x times 4x plus 1. My denominators are the same, so I may add my numerators. I will have 12x squared plus 12x plus 3. My denominator is my LCD, 4x times 4x plus 1. I have found my LCD, I have found my equivalent fractions, I have added my numerators, I have written my LCD for my denominator. The last step is to see if I can reduce this fraction. To reduce this fraction, I see if I can factor this numerator. There is a common factor of 3 in each numerator term, so I will factor the 3 out. When I factor 3 out of 12x squared, I am left with 4x squared. When I factor 3 out of 12x, I am left with 4x. When I factor 3 out of 3, I'm left with a positive 1. In the denominator, I have my 4x times 4x plus 1. Do you recognize the 4x squared plus 4x plus 1? Can we factor that? It is a perfect square trinomial, isn't it? Let's factor it. Since we recognize it's a perfect square trinomial, we know that it factors as a binomial squared. We need to get the terms for the binomial. The first term is whatever we squared to get 4x squared, that would be 2x. We will get the sign from this middle term, and the last term will be whatever we squared to get this 1, which is 1. For my denominator, I have 4x times 4x plus 1. Do my numerator and denominator have any common factors? The answer is no. So I cannot reduce this fraction, but since I already have it in factored form, I'll just leave it in factored form. That completes this section. Now let's move to the blue set of problems. Trinomial denominators. Here are the problems I shall work in this set of problems. I'd like to begin by reviewing how to find the least common denominator. To find the LCD, we first factor each denominator into its prime factors. Then write each different prime factor raised to the highest power that it occurs in any one denominator. Let's begin with problem 1. Perform the indicated operation. The indicated operation is subtraction. We are subtracting fractions, so we know we need to find the LCD. Let's rewrite each fraction and let's factor the denominators. I will write the 3x. X squared subtract 4 is the difference of squares. It will factor as x plus 2 times x minus 2. I will write the second fraction. When I look at its denominator, x squared minus 4x plus 4 is a perfect square trinomial. It will factor as x minus 2 squared. When I find the LCD, I need each different factor, which would be x plus 2 and x minus 2. The x plus 2 is raised to the first power, so I will only use it raised to the first power. On the x minus 2, the highest power it is raised to is the second power, so I will have to use x minus 2 squared. I have found the LCD. Now let's get my equivalent fractions. Let's take this first fraction. Let's rewrite it. Let's look at its denominator. What is the needed factor so that the resulting equivalent fraction will have a denominator that's equal to the LCD? Well, I have the x plus 2. I have one of the x minus 2's, but I need another x minus 2. So I will multiply by x minus 2 over x minus 2. On my second fraction, I will write the numerator. In the denominator, I have the x minus 2 squared. I have two factors of x minus 2. The factor I need is the x plus 2. So I will multiply by x plus 2 over x plus 2. Now, when I work with my fractions, on this first fraction, I will multiply out my numerator. I have a monomial times a binomial, so I will distribute the 3x to the x and the minus 2. 3x times x is 3x squared. 3x times minus 2 is minus 6x. I write the denominator in factored form. Let's write the x plus 2, and I may write x minus 2 times x minus 2, but I'm going to write it as x minus 2 squared. For my second fraction, let's go ahead and write the denominator. Let's multiply out the numerator. I have a binomial times a binomial, so I need to use FOIL. 2x times x will give me 2x squared. For an outer term, 2x times 2 will give me 4x. For an inner term, minus 1 times x will give me minus x. 4x minus x will give me a plus 3x for a middle term. For my last term, negative 1 times 2 will give me negative 2. My denominators are the same. I am ready to combine my numerators. I will write my denominator in factored form. I will write my first numerator, 3x squared, subtract 6x. Because this is subtraction, the subtraction will change the sign of each of these terms, so I will apply the subtraction sign to each of these terms. When I apply the subtraction to 2x squared, I will have minus 2x squared. When I apply the subtraction to a positive 3x, I will have minus 3x. When I apply the subtraction to the negative 2, minus a negative 2 would give me plus 2. Combining like terms, 3x squared minus 2x squared would give me 1x squared. Minus 6x subtract 3x would give me a minus 9x, and I am left with a positive 2. All over my denominator, x plus 2 times x minus 2 squared. Now my last step is to see if this fraction will reduce. Before we do that, let's review the steps. We found the LCD. We multiplied each fraction by the needed factors so that the resulting fractions had a denominator of the LCD. We were then able to subtract the numerators, and we combined like terms. We wrote the LCD as the denominator, and now we check to see if we can reduce. Can we factor the numerator, x squared minus 9x plus 2? The answer is no, we cannot. Since the numerator and denominator have no common factors, this is my final answer. Problem number 2. Perform the indicated operation. The operation is subtraction. I am subtracting fractions. When I subtract fractions, I need an LCD. Let's find the LCD. Let's rewrite each fraction and let's factor the denominator. For my first fraction, I will write 2x plus 1. When I factor the denominator will factor as x plus 3 times x plus 2. On my second fraction, let's write the numerator, x minus 4. When I factor my denominator, x squared plus 6x plus 8 will factor as x plus 2 times x plus 4. Let's figure out what the LCD is. Let's get each different factor. I have a factor of x plus 3. I have a factor of x plus 2. I've already used the x plus 2. I will write the factor x plus 4. Each of these factors is raised to the first power, so I will use them raised to the first power in the LCD. Let's get equivalent fractions. Let's write my first fraction. Let's figure out what I need to multiply by so that the resulting equivalent fraction will have a denominator of x plus 3 times x plus 2 times x plus 4. I have the x plus 3, I have the x plus 2, I need the x plus 4. So I will multiply by x plus 4 over x plus 4. On my second fraction, I'll write the numerator, I will write the denominator. Let's figure out what we need to multiply by. I have a factor of x plus 2. I have a factor of x plus 4. The needed factor is x plus 3. So I will multiply by x plus 3 over x plus 3. When I find my equivalent fractions, I multiply out my numerators, leave the denominators in factored form. So on this first fraction, I am multiplying 2x plus 1 times x plus 4. I am multiplying a binomial times a binomial. I will use the FOIL method. 2x times x is 2x squared. For an outer term, I will say 2x times 4, which is 8x. For an inner term, 1 times x is x. 8x plus 1x will give me 9x for a middle term. For the last term, 1 times 4 is 4. Write the denominator in factored form. For my second fraction, I will multiply out my numerator. I have x minus 4 times x plus 3, binomial times binomial. I need to use the FOIL method. For my first term, x times x will give me x squared. For my outer term, x times 3 will give me 3x. For my inner term, minus 4 times x will give me minus 4x. 3x subtract 4x will give me a minus x for the middle term. For my last term, negative 4 times 3 will give me negative 12. Write the denominator in factored form. My denominators are now the same. The factors are in different order, but they are the same. So I may combine my numerators. I will write my denominator, which is the LCD. When I get ready to combine my numerators, I will write my first numerator. Once again, I am subtracting, so I have to apply the subtraction sign to each term in the numerator of my second fraction. When I apply the subtraction to x squared, I get minus x squared. When I say subtract a negative x, I get a positive x. When I say subtract a negative 12, I get a positive 12. Combining like terms, 2x squared subtract x squared will give me x squared. 9x plus 1x will give me 10x. 4 plus 12 will give me 16. All over my denominator, x plus 3 times x plus 2 times x plus 4. My last step is to see if I can factor my numerator. Does x squared plus 10x plus 16 factor? It does. It factors as x plus 2 times x plus 8. I write my denominator. For this fraction, since my numerator and denominator have a common factor, I may reduce. I may think x plus 2 over x plus 2 is equal to 1. My result is x plus 8 over x plus 3 times x plus 4. This is my final answer. Problem number 3. Perform the indicated operation. I would like for you to work this problem. After you have worked it, I shall give you the correct answer and shall work the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Let's look at the answer. Did you get this for the answer for problem number 3? If so, good for you. I shall finish this tape by working this last problem. The indicated operation is addition. I am adding fractions, so I know I need to find the LCD. Let's rewrite each fraction and let's factor the denominators. On the 2x squared plus 4x, I have a common factor of 2x. When I factor 2x out of 2x squared, I am left with x. When I factor 2x out of 4x, I am left with 2. On the second fraction, when I factor x squared minus x minus 6, it factors into x plus 2 times x minus 3. I am now ready to find my LCD. Let's get each different factor. I have a numerical factor of 2, a variable factor of x, a variable factor of x plus 2. I've already used the x plus 2, and I have a variable factor of x minus 3. Each of these factors, 2x, x plus 2, x plus 2, x minus 3, is raised to the first power, so I only need to use them raised to the first power for my LCD. Let's find equivalent fractions. Let's take my first fraction. Let's figure out what I need to multiply it by so that the resulting equivalent fraction has a denominator of my LCD. I have my 2, I have my x, I have my x plus 2. I need to multiply by x minus 3 over x minus 3. For my second fraction, write my 5, write my denominator factors. What factors do I need to multiply by? Got the x minus 3, the x plus 2. I need to multiply by the 2x. I will multiply by 2x over 2x. Let's multiply out the numerators. Let's write the denominators in factored form. On the first fraction, I will write the 2x, the x plus 2, the x minus 3. In the numerator, I am multiplying x minus 2 times x minus 3. I am multiplying a binomial times a binomial, so I will use the FOIL method. X times x will give me x squared. For an outer term, x times negative 3 gives me negative 3x. For an inner term, negative 2 times x will give me negative 2x. Negative 3x subtract 2x will give me negative 5x. For a last term, negative 2 times negative 3 will give me positive 6. For my second fraction, let's write the denominator in factored form. I will write the numerical factor 2, then x, then my x plus 2, and my x minus 3. In my numerator, I'm multiplying 5 times 2x, and the result is 10x. My denominators are now the same, so I may combine my numerators. I will have x squared, subtract 5x, plus 6, plus my 10x, all over. Write the LCD as the denominator, 2x times x plus 2 times x minus 3. Combining like terms, I will write my x squared. Minus 5x plus 10x will give me a plus 5x, and I have my plus 6. Let's write the denominator. Let's review the steps. We found the LCD. We found the needed factors and multiplied, so we had equivalent fractions. We added the numerators. We wrote the LCD for the denominator. And for the last step, we need to check and see if we can reduce. Can we factor this numerator? Yes, we can. It factors as x plus 2 times x plus 3. We will write that over our denominator, 2x times x plus 2 times x minus 3. The x plus 2 is a factor in the numerator and the denominator. We know that x plus 2 divided by x plus 2 is 1, so we may cancel the x plus 2's, and the result is, in the numerator, x plus 3. In the denominator, I will have 2x times x minus 3. That is my final answer. That completes the adding and subtracting algebraic fractions with different denominators lesson. Please rewind the tape before you return it. Thank you.